Hello and welcome to my third video for making an action RPG inside of GameMaker. In this video, we're going to get the player movement working. We've hopefully built a stage and we've set up doodads to collide with the player. But we're going to actually work on getting the player to be able to walk around, experience those doodads, and then set up some invisible walls for the rest of the terrain, because right now tiles don't have any collision. So let's kind of begin with that. So for the sprites, I'm going to make another folder for player related sprites. So I'm going to create another group called player. And I'm going to create a few new sprites. So the first up is going to be a new sprite. And in the next video, we're going to set up the animations. So we'll go through and create a lot of animations. And so I'm going to name this in the same convention that I was going to name them in. SPR underscore idle underscore, SPR underscore player underscore idle underscore down. And so what that means is that this is a sprite, this is a player sprite as opposed to a monster sprite. The idle is which animation it is. So the player idling, just kind of standing there. And then down is the direction they're facing. So we're going to do 4 different directions of animations. So we will have an idle right, an idle left, and idle up. But right now, we're not going to worry about animations. We're going to do that in the next video. We're just going to get a graphic for the player. So hopefully you found a sprite sheet that you'd like. So you'd want to import and go to our player folder. I don't want to use an entire sprite sheet. Actually, that gets a little messy. So you'd want to use a graphics editing program like GIMP or Photoshop to chop it up into smaller pieces. Just because the big sprite sheet, you can use it, but it is a bit more of a numerical hassle. So I'm just going to pick this player stand down sprite and load it up. Now the second thing that's very important, I know this is very important, kitty. Oh, Angie's not having a good time. Oh, you're on my lap, cat. Bye. All right, so with that problem solved, we were going to set the origin of the sprite. And it is important that all of the sprites have the same origin. Otherwise, when we switch between animations, it's going to pop and change and flicker. And I think the best origin for this type of game is the bottom center. Basically, the player is standing where their feet are. And then that's going to be where we use the calculations for determining what height the player is for the stacking order for the depth variable. So I'm just going to pick that. As far as collision mask, well, we are going to set a different collision mask on the player than we would than building it into the sprites, because we are going to have several sprites. So we can still set it to what I would set it to, but we won't need to worry about this. We're going to set it to manual, and I'm going to make it an ellipse, a spherical hitbox. Because we don't want the head to necessarily count, because it's kind of from a perspective. We only really want to count the lower half of the player as something that you can hit. And so the settings I would use is left 16, right 47, top 32, and bottom 63. So it kind of creates a circle down here. That's where hits would register for the player. Then while we're still here, let's load up what we will consider to be kind of our master copy of the collider. So that's going to be a new sprite. This will be called SPR underscore player underscore collider. And that's what this graphic is for. This is just a guide for me to make sure that I set my collision. Make sure that your origin is set to the bottom center. This is just a guide to make sure that when I'm setting up my spherical hitbox, I am setting it to kind of the right thing. And so you can see that just by doing this kind of organically, I ended up getting pretty much the same settings. The bottom of this should be 63 though. And this will be the collider that we use for the player. So we'll X out of that. And now we're going to create the player object. So we're going to write, well, let's make a folder for it. Create a group called player. And inside that group, we will create our new object. This object will be called obj_player. And the sprite that we're going to give it. And now bear in mind that the animation will change based on what we're pressing. But I'm just giving it that sprite so we can see a player. Now, where it says collision mask, instead of choosing same as sprite, I am going to choose that other one that we created, so that we don't really need to set the collider on any of the animations for the player, that this will override that. Because ultimately, we are going to very quickly have 12 different sprites for the player, 3 different animations in 4 different directions. And we don't really want to set that collider on all 12 of them. So now we've got that. Let's set up, I guess let's start with the step event. So the step event, we're going to kind of call the things that we need to do here. So we're going to first set depth and then handle movement is our goal for this. So depth was a very simple command. It was just depth equals -y. So the y position of the player becomes the stacking order for the sprite. Now we're going to read the controls. And this is kind of a standard way to read multiple inputs. We're going to say make a variable called write, and that will be equal to keyboard_check VK, virtual keyboard, or virtual key, write, or by using those 2 vertical bars, keyboard_check, open parentheses, ord D, capital D. And that's so that we could use either the arrow keys or WASD to control the player. And then we'll do the same for left. We could copy and paste it, maybe make it a little bit quicker. So it would be the key left, and then the A key, and the variable name would be left. And then we'll do the same for up and down. So I'll do down first. So down will be the VK down, and that's the S key. Up is the W key. And that will be VK up. So let me just reorder this. This is going to be the order that I present a lot of things in. When we start rigging up animations, we need to kind of have a set order that we do things in. Or when we call methods, we'll need to have a set order. The order I'm going to try to go with is left, right, down, up, because the thought process is this is -x, +x, -y, +y. So that's just the order I'm going to be considering these 4 directions in, is left, right, down, up. All right, so we've read the controls. Now, because the movement script is actually going to be kind of long, let's make it into a script file. That way, other characters, like this isn't going to be unique to the player. Other characters could use the same movement script so that this code could be reusable. So we're going to create a new script. And I'm just going to call this SCR_movement. Now the name of this function doesn't have to be the same as the name of the script containing it. So I could just rename this to movement because that's really what I want it to be called. And I want to take in 4 parameters. I want to take in the movement keys. So we're going to take in left, right, down, and up. And I suppose for syntax sake or style sake, we'll put underscores in front of them. GameMaker seems to prefer parameters begin with an underscore. So here's our function called movement, and it's going to take 4 parameters: a left value, a right value, down value, and an up value. So inside of here, we need to calculate a couple things. We need to calculate the overall horizontal movement of the player, and that is going to be the right minus the left. Now, when you're pressing a key, it's going to be either 1 or 0 or some kind of decimal in between there if you're using a joystick. By doing it this way, if left is 1, meaning they're pressing the left key, and right is not being pressed, you end up with the expression 0 minus 1, which would give you -1 for horizontal, which corresponds with the direction on a coordinate plane. Left is negative. And so we'll do the same for vertical. So we will do down minus up. So we'll call this calculate the net movement. And again, this is going to be on a scale from -1 to 1. So the other thing that kind of comes up is we want to address the diagonal vector issue. So what the diagonal vector issue is, I want to pull up MS Paint. I don't think, I might have talked about this at some point. But if we press right and we have a magnitude of 1 for that direction, and we press up and we have a magnitude of 1 for that direction, and if we do the Pythagorean theorem about this, essentially calculating the distance, so this vector here is actually going to be about 1.4 because it's going to be the square root of 2. And so the player would actually be traveling 44% faster diagonally than they would be in any of the cardinal directions. So we want to normalize this vector so that it would only be at most a magnitude of 1. So we need to calculate the magnitude of the movement vector. So that would be, we can call it move length. And the formula for that is the square roots of the horizontal action squared. So we can just do horizontal times horizontal plus vertical times vertical. Basically the Pythagorean theorem. And then if that amounts, so if move length is greater than 1, then normalize the vector. So to normalize the vector, you just divide, because this would be equal in horizontal and vertical, we can just divide horizontal by the movement length, and that will normalize this. Kind of sad that GameMaker doesn't have built-in vector normalization. A lot of game engines do, but it does not. So now, if you are getting annoyed by these warnings, and actually I probably should change the style of my variable here. I'm using more of a C style. You can just right-click these and tell it to configure the severity to ignore. So if those little blue squiggles are annoying you, you can just ignore them. But I'll take its advice and I will fix my variable to be more in line with GameMaker conventions, which would be to be move underscore length. Like that. All right, so we've normalized the vector. Now, let's jump into moving right away. Then we're going to implement in kind of an inertia system, an acceleration and a sliding, so that we could have friction play a role in our player movements. So we are going to use the command move underscore and collide. Move and collide is actually a really powerful method that moves the player and then respects the colliders of the objects we specify. So the first parameter is your horizontal movement. You can actually see down here what the parameters are. Horizontal movement, followed by vertical movement, followed by which objects should we consider collidable. Now you can put all for now, but what we really should do is define a list of impassable objects. So I'm going to do that real fast inside the player. Inside of the create step. Normally I'd want to put it as an instance variable under variable definitions, but they don't seem to like arrays very much. So we're going to declare an array called impassable underscore objects. These are things that we're not allowed to pass through. And so we right now only have one, which is the doodad parent. But we can add more to this array as we start to add more things. Like we could start adding the parent for like walls. We could potentially add enemies if we don't want to be able to push enemies. So this will be a list of things that we're not allowed to move through. So we go back to the movement script. And instead of all, let's just say impassable underscore objects. Now this does mean whatever actor that's using this method will need to have that defined, otherwise it will crash. But that's not that hard. We just need to make sure everything that's going to be using this movement script has that array declared. So inside of our step method, we just need to call that movement script. And then that's going to handle our movement. And again, when we get to enemies, we could have their artificial intelligence, instead of actually using keystrokes, we could have it calculate things that it wants to do and feed it in this information. So we could hit play. Oh, we didn't add the player to the map. So let's go do that. So let's go to our room. And then on the instances layer, we want to drag in an object player. Then hit play. Now, we are going to deal with the camera in a second, because right now it's showing us the entire world. And we are moving, we're moving kind of slowly because it's actually only moving 1 pixel at a time. We didn't multiply it by anything. But you can see that I do bump into things. When I try to move against this tree, I can't move. So if you wanted this to be a little bit more exciting, we could just like multiply this by like a move speed. So multiplying it by 5. And we actually kind of get a smooth movement around the tree. So, but one thing that I want to change is the fact that the player, basically when you start pressing a key, you immediately move in that direction, and then when you release the key, you immediately stop. And that is a little bit unrealistic. It would be a better feel if there's a very subtle ramp up to your max speed and a very subtle slow down to a stop. Not enough that it feels like you're kind of like slipping on ice, but enough that it's not just like you release the key and you just immediately stop. And then also this infrastructure will allow us to implement getting knocked back by monsters and having kind of a little bit of hit physics. Although before we get to that, let's fix the room so that it tracks only the player. This is very easy for us to do. If we open up the room and go to viewports and cameras, tell it to enable viewports, open up viewport 1, check the box for visible. You can see that the screen size has appeared here. Adjust this to your screen resolution. For now, I'm just going to leave it to the defaults. And then we can set the object to follow. This is going to be what the camera tracks. And obviously, I want the player to be what it tracks. Now, the border is how close the player has to get to the edge of the screen in order for the camera to follow the player. So by default, it's 32 pixels, meaning the camera is not going to track the player until I'm within 32 pixels of the edge of the screen. But I would rather it center on the player than only track when we're like basically walking blindly into danger. So typically you want this to be half of the width of the screen. I don't know if I can just type that in there. It does not let me use the division symbol. I don't feel like that's right. That's the weirdest half ever. So typically by setting the margin to half of the screen width, you're guaranteeing that the player is always within that margin to cause the screen to want to follow the player. So that it'll always keep it focused on the player. Now, alternatively, you could just not bother with the math and just set this to like 9999, and in which case the screen will always do its best job to track the player. So you could just ignore that math and just go 999 and it will do the same thing. All right, so that's going to get it to follow the player. Now let's continue updating the player's movement script so that we can have a little bit more of a refined movement behavior. So inside of the player, we are going to need to declare a few variables. So the first one is a move underscore max. This is the maximum move speed we're going to allow the player to reach. So we could start with 5 and then go from there. Move underscore acceleration. That is how fast the player increases their speed per frame. We'll set it to 1. So effectively, we are going to reach our max speed in 5 frames, which is 5/60 of a second. Move underscore friction. This is how fast our speed will decay when we're not moving, and we'll set that to 1. Friction will only apply if we're not pressing a key, or if we're stunned and getting knocked back by something. You'll notice I'm not using the variable, built-in variable for friction, because I'm not actually using GameMaker's direction and speed variable. We're kind of handling the physics ourselves and the movement ourselves. Next up is move underscore direction. This is the angle of my movement. And then lastly, move underscore magnitude. This is the strength of my movement vector. So we need these variables for us to kind of simulate a movement system on our own, kind of independent of GameMaker's movement system. All right, so we're going to go back to our script and then put these variables to use. So after we've normalized the vector, what we'd want to do is start setting up the kind of adding on to the existing of the movement. So we're going to add the new amounts of movement to last frame's movement vector. So what that means is we're going to create a variable called move_x, and that's going to take my old horizontal movement, multiply it by my movement acceleration, and then add on the old information. So we're going to use this command called length direction x on move_magnitude, comma move_direction. And then we're going to do the same exact thing, but for y. So this variable is going to be called move y. We're going to take the horizontal motion, the vertical motion, multiply it by my acceleration, and then we're going to get the y amount. So if you're familiar with the physics term, we're componentizing the vector, because right now, to use MS Paint as an example, if my player is here and I'm moving in this direction by a speed of 4, that can be stored as a vector of magnitude 4 of angle 0. But we want this in x and y, so instead of a radius and a number of degrees, we want an x components and a y components. So that would be, I guess we kind of do it like that. So as a vector, this would be 4, 0. If I was going in this direction by a magnitude of 4, well, this is a 45-degree angle. So the vector, the magnitude would be 4, the direction would be 45, and then when we componentize that, I want to say this would be 2 square root of 2, comma 2 square root of 2. And so this is the value that's right here. We're taking the old movement information and converting it into an x value and a y value so that we can add on to it the amount that the player is pushing on the keyboard. So because right here, this is what they're pushing on the keyboard, that frame. This is the old information. So now we're going to recalculate the vector as a magnitude and direction. So that's going to be move_direction. The easiest way to do that is the point direction command. So from 0, 0 to move x, comma move y. What that does is that just basically whatever x and y value, it calculates the angle. And then movement magnitude is that formula we used before, but we want to cap it to our move speed. So we're going to take the minimum of the square root of move x times move x plus move y times move y. So that's the magnitude of the move vector, comma, my move_max. So that it's going to take the minimum of these. So if this ends up being a value of like 6, but my max movement is 4, it's going to take 4 as the magnitude. Now we want to apply the friction. So if we're not moving, so if we're not pressing any keys, and that we have some kind of movement magnitude here. So if, now the easiest way I can think to do this is if we just take the absolute value, I'll put that in parentheses. The absolute value of my horizontal motion plus my absolute value of my vertical motion, and that's the motion of the keyboard. Horizontal and vertical were the ones that we calculated up here that are based off of the key presses. So if we're pressing keys, if that's less than 0.1, and we have a movement vector. So the first part here is checking if we are pressing a key. The second part is checking if we actually have movement. And this part could be a little bit tricky. Trying to think if there's a easy way to do this. We could do move magnitude equals the absolute value of move. So we take the old magnitude, we absolute value it, we subtract off the friction, and then we would want to minimize or max that with 0. So if my movement vector was, let's say my movement vector was 1, and the friction's really high, the friction's like 2, and this makes it -1, well, we will still cap it at 0 because friction shouldn't cause you to move backwards. And then we can restore its original sign by multiplying by the sign of the original magnitude. And now that we've calculated all of this, we can then use that as our movement instead of just the basic key presses. So we can feed in length direction x of move magnitude, comma, move direction. And then we're going to do the y value for here. And then impassable objects is still our last parameter there. So we'll hit play. And now you can see that there's a slight ending to the player's movement. And it doesn't really affect too terribly much. We can still push against the tree and it would wrap us around the tree. We still need to add invisible walls to things like the tree trunk there. And if you feel like the movement's not snappy enough for you, you could try to increase the acceleration of the player. So that will bring the player up to their maximum vector quicker over less frames. And so you would see a quicker movement in response. All right. Now, we are colliding into these grass things because the grasses are part of the doodads. So that is one quick fix I want to make. Inside of the doodads, I want to make a type of doodad parent that is separate from this one. So I'm going to create a new, I'm going to duplicate this, and I'm going to call this doodad parents underscore no clip for no clipping, so it doesn't cause collisions. And I'm going to switch the grass over to that other parent. So when we actually play this, then now it's no longer in the list of collidables. So you can see that I will pass through the grass, but I'll still hit the tree, and I'll still hit the rocks. And our code for layer, our depth is working because you can see the player's behind the rock there, but here the player's in front of the rock. So that's been working the whole time. So right now we've got a pretty good movement system working. We've got our doodads blocking our movement. But what we need next is going to be animation, and we also need invisible walls. So we'll start with adding the invisible walls for like the river and such, and then we're going to put an animation for the player. And I believe that's all we need to worry about for this video. So we've got our movement as a separate script, which is very convenient, and we can reuse it. So I will see you in the next video. We're going to set up some animation for the player. So thank you for watching.